Computation of regression equations for heavy data sets takes place with the help of softwares or graphing calculators. But unless and until we attempt to explore the calculations manually, the concept is not that clear to us. Hello everyone, I am Mrs. Shumala Hassan, Department of Humanities, the Bhopal School of Social Sciences. So in this module, we are going to apply regression analysis to a fictitious data set. Secondly, we will go on to compute the regression equations manually, that is by hand. And thirdly, we will go on to interpret the results of our calculations and predict certain values based on our calculations. So to begin with, let's analyze a problem statement first. Last year, 5 randomly selected students took a math aptitude test before they could begin a statistical course being offered by the college. Now the statistics department had 2 questions in mind. Question number 1, which linear regression equation is going to best predict the scores of the statistics test based on the math aptitude test that the students had already taken? And question number 2, if a student scores an 80 in the math aptitude test, can we predict her score in the statistics test to come? For this, we are going to construct a regression equation by calculating the slope and the intercept values by hand, that is manually. Now a very important note here. Do not use the values of the independent variables to predict the values of the dependent variable that are outside the range of the values that are used to calculate the equation. Here the values of your independent variable, that is the scores in the math aptitude test, ranged from 60 to 95. So therefore, whenever you are calculating or predicting the values of your dependent variable, make sure that you do not extrapolate beyond the upper value of your data set values that were used for computation of equations. So therefore, your values that you take for predictions should be between 60 to 95. So let's begin with our calculation of regression equations manually. Here is the data set that has 2 variables, xi and yi. Xi denotes the scores of the 5 randomly selected students in the math aptitude test. That is going to be your independent variable. And yi denotes the statistics scores that those same students have taken up the course and then they have got the scores in statistic test. So let's start with the calculation. In the first step, we need to calculate the mean of the xi series and the yi series. Here, we are going to calculate the mean, the simple arithmetic mean, with the formula x bar is equal to summation of xi divided by n, and y bar is going to be summation of yi divided by n. It's the calculation of the simple arithmetic mean in the individual series. So therefore, the first step is to take out the summation of xi. Here if we calculate the total of this column, it comes out to be 395. And here if we take out the summation of the yi series, the answer comes out to be 385. The value of n is the number of observations here. Now the number of observations is 5, as we had selected 5 students randomly. So therefore, the calculation goes as 395 divided by n, that is 5, and here 385 divided by 5, that is 5 here. So here the answer is going to be your, this is going to be 79 and this is going to be 77. A tip here, whenever you are watching such kind of videos, always take a moment, pause the video, calculate yourself and then cross-check the values that the video is giving you. Step 2. Here we have got the means. X bar is equal to 79 and y bar is equal to 77. Now let's take the deviation of the x series from its mean. So therefore we have to deduct the value of the mean, that is 79 x series mean, from the respective values of xi. Here it is 79, so you are going to deduct the value 79 from each of these values. So here 95 minus 79 will give you a 16, 80 minus 79 will give you a plus 1, 70 minus 79 will give you a minus 9, 60 minus 79 is going to give you a minus 19, and 90 minus 79 is giving you a plus 11. Let's come to the next step. Take the deviations of the y series by deducting the y bar, that is the mean of the y series, from individual values of y1. Here we are going to deduct 77 from 85, so you get a 8 here. Next is 90 minus 77, that is going to be a 13. Next we have 60 minus 77, that is going to be minus 17. Next value is minus 7, and lastly 80 minus 77, that is 3. Next step, multiply the capital X and capital Y. Here please see the difference. This is a small xi and this is capital. Okay. So in this column we are going to multiply the capital X and the capital Y columns to find out the values of xy column. So here 16 multiplied by 8 would give you a 128. Next is 13, that is 13 multiplied by 1. Next is 17 multiplied, this is minus 17 and minus 9. This would give you a plus 153. Next is minus 19 multiplied by minus 7 is going to give you a plus 133. And lastly, we are going to multiply 3 into plus 11, that is 33. Now here you have to find out the total of the xy column. So summation xy is going to be equal to 460. Now let's calculate the last column. The last column is going to be the square of the capital X column. Here the values that you have to find out is the square. 16 into 16 is 256. Next is 1. Next 81. Next one 361, and the last one is 121. Now for your calculations you require the summation of the x square series also. So therefore summation of x square would be equal to, calculate the total of the last column and you get the answer as 820. Always remember to write the things that you require to put in your formula separately. Here summation xy is required, so you write down summation xy as 460, and then you require summation of x square series. So here summation of x square series is 820. Now let's recall the regression equation. Y, that is the dependent variable, is equal to a plus bx. Here we need to find out the values of a and b. Now how do we proceed? Let's first find out the value of b. So b is equal to summation of capital X y divided by summation of x square. Here we put the values. Summation of xy we have already written as 460 divided by 820. The answer is going to be 0.56. Please recall that this is also known as the y-intercept. Now we need the value of a also. So a is equal to y bar minus b multiplied by x bar. Here y bar is the mean of the y series and x bar is the mean of the x series. We already have these values calculated with us. So therefore, now we put the values in the formula. Y bar is 77 minus B is 0.56 as we have already calculated here, multiplied by 79. So when we multiply these two, 0.56 multiplied by 79, the value you get is 44.24, and we are going to deduct that from 77. And finally, the answer that you get is 32.76. Please pause the video, calculate yourself, and then reaffirm your answers. So now we have got all the values to calculate our regression equation. Here, now we frame the regression equation. Yi is equal to A, that is 32.76 plus Bx. That means 0.56 multiplied by 80. Because we have to solve that if a particular student is scoring an 80 in the math aptitude test, what is going to be her score in the statistics test. So therefore, let's further go on calculating this. The answer when you multiply this will be equal to 44.80. So here we have the value after multiplying 0.56 and 80, 44.80. Add these two and you will get the final answer as 77.56. So if a particular child is scoring an 80 in the math aptitude test, it is predicted that she is going to get a score of 77.56 in the statistics course. So this is the method by which we can calculate the regression equations manually, that is by hand, and predict the values of your dependent variables based on the changing values of your independent variable.